When you think of asthma, what's the first thing that comes to mind? Probably airways tightening up, right? Making it so hard to breathe. But what if I told you there's a more sinister, hidden culprit at play? Today, we're diving deep into the lungs to uncover a secret saboteur, and what we find, well, it just might change how you think about this disease entirely.
See, we all think an asthma attack is about muscle constriction, but in the most severe cases, the ones that are actually fatal, something else is going on. There's a substance that is literally clogging the airways from the inside out, and that substance is mucus.
So, to really get this, let's approach it like a detective story. We're going to treat the asthmatic airway like a crime scene. We need to dust for prints and examine the evidence left behind to figure out what's really going wrong.
And this quote right here from Dr. John Fahey really sets the stakes. This is not just about a little bit of phlegm or a cough. He's saying that in the most tragic cases, people die because their airways are physically blocked by plugs of mucus. That right there is our smoking gun. So what is this stuff anyway? Well, mucus isn't just slime. It's this complex, goopy gel. And its main building block is a huge molecule called a mucin. You can think of mucins as the special ingredient that gives mucus all of its thick, sticky, gel-like superpowers. Okay, so if the problem is way too much of this mucin-packed mucus, the next question is pretty obvious. Where's it all coming from? We need to identify our main suspect, the cellular culprit behind this overproduction.
And here it is. Folks, meet the goblet cell. Now, in a healthy person, these cells are the good guys. They're essential little defenders, making a thin mucus layer to trap dust and germs. But in our investigation, this helpful worker is about to become our prime suspect.
And just look at the difference here. A healthy airway has a nice, balanced number of these goblet cells. But in an asthmatic airway, we see something called goblet cell hyperplasia. Now, hyperplasia is just a fancy medical word for way too many cells. They've multiplied that crazy, basically turning the airway lining into a mucus factory that is working 24/7. And the evidence is just staggering. Research shows that in people with asthma, the number of these little mucus factories is 2.5 times higher than in healthy people. That's a fundamental re-engineering of the airway, and it's a system that's now built for massive overproduction. So, what does that lead to? Well, more factories means more product, right? And this chart shows it perfectly. All those extra goblet cells result in a volume of stored mucus that's 3 times higher than normal. The airways are literally preloaded with this thick, sticky gunk, just waiting. But that just brings up a new question in our investigation. Are these goblet cells just going rogue? Are they acting on their own? Or is something else pulling the strings? It's time to look for the masterminds. And it turns out, no, the goblet cells are not acting alone. They are absolutely taking orders. The masterminds here are part of our own immune system, specifically cells called CD4 plus T cells. These T cells release chemical messengers, things called Th2 cytokines, with names like IL-4 and IL-13. And these aren't just random signals. They are direct orders. They act like growth factors, basically screaming at the airway, make more goblet cells now. And here's exactly how that chain of command works. First, the T cells pump out those cytokines. Then, those cytokines hit the lining of the airway and appear to flip a very specific genetic switch. They crank up a gene called MUC5AC, which is the main instruction for making that sticky mucin. And that genetic signal is what ultimately drives the creation of all those new goblet cells. And here is the proof, right from the genetic level. This chart shows us the expression of that critical MUC5AC gene. In people with asthma, it's about 60% more active than in healthy people. The immune system is sending that make more mucin order loud and clear. Okay, so we've got our suspects, the goblet cells. We've got our masterminds, the cytokines. We know the airways are packed with 3 times the normal amount of mucus. Case closed, right? Not even close. Our investigation is about to take a very, very sharp and unexpected turn. Now, to get the twist, you first need to understand how mucus gets released. It is not some gentle ooze. The source material describes it as an explosive eruption, like a jack-in-the-box. The mucin is packed super tight inside the cell, and when the latch is thrown, it just explodes outwards, expanding like crazy as it hydrates in the airway.
So that leads to a really logical conclusion, doesn't it? If someone with asthma, whose airways are already overloaded with these mucus-filled jack-in-the-boxes, breathes in an allergen, everything should just erupt. It should cause that dangerous airway plugging we talked about. Seems totally obvious. But incredibly, the direct evidence we have from human studies says, no, it doesn't happen. And this, my friends, is the central mystery of our case. The logical trigger doesn't spring the trap. So what on earth is actually going on here? Okay, let's look at the evidence. In a study, people with asthma were exposed to an allergen. And just look at this chart. The immune system definitely responded. There's a huge spike in inflammatory cells, which shoot up more than 4 times in just 1 hour. So the body is clearly sounding the alarm and launching an immune response. But then look at this. This is just astounding. The amount of mucus stored inside those goblet cells, it doesn't go down. It's not being released. In fact, 24 hours later, it's actually gone up a little bit. Even with the allergen alarm blaring, the jack-in-the-box stays shut. This changes everything we thought we knew. This discovery, this wild plot twist, is actually the key to cracking the whole case. It tells us that making the mucus and releasing the mucus are 2 completely different processes. And if we can figure out the release mechanism, maybe we can control it. And here is our final clue. Scientists have found a key player in this release, a molecule called the Marx protein. The best way to think of it is as the little latch on the jack-in-the-box. It physically holds the stored mucus to the cell's internal skeleton, getting it primed and ready for that explosive release. It's the critical switch. So this is the big takeaway. The mucus problem in asthma isn't one problem, it's 2. Problem number 1 is the immune system telling the body to make way too many mucus factories. That's the hyperplasia. But problem number 2 is a totally separate mechanism that actually pulled the trigger and causes the release. Scientists call this degranulation. And this opens up a whole new strategy for treatment. Most current asthma drugs don't really target mucus at all. But now, understanding that degranulation is its own separate process gives us a brand new target. Imagine a drug that could specifically block that Marx protein, or some other part of the release mechanism. It would be like putting a safety latch on the jack-in-the-box, preventing it from ever springing open. That would be an absolute game changer. And that leaves us with one final and really hopeful question. By unraveling this incredible mystery, from the overproduction of mucus to its explosive but controllable release, we've uncovered a whole new frontier for treatment. Could mastering this jack-in-the-box mechanism finally be the key to preventing the most dangerous outcomes of asthma and helping millions of people finally breathe free?